So, the idea of this talk started because I hear a lot of concerns about security when you start dealing with DevOps, and mostly, honestly, there's some facts in there, but mostly it's myths. So I'll talk a bit about that, what the actual facts are, but mostly we'll talk about the myths and what you should actually be concerned about versus what you shouldn't be concerned about. So, as Josh said, I'm David Mortman. I'm the Chief Security Architect for a Dell product called Instradius, otherwise known as Cloud Manager. That's all you hear about the product today. I used to be the CISO at Siebel Systems. For anyone here have to use Siebel software in the past? Anyone? I'm sorry. That's all I can say about that. I'm sorry. I'm on Twitter as Mortman. I'm a baker. I have a pizza oven. If you want to talk baking afterwards, let me know. Has nothing to do with DevOps whatsoever, but it is tasty. So if you're into gluten, talk to me afterwards. So before I dive into our actual first thing, who here is actually familiar with DevOps, has to do DevOps on a regular basis? Okay, a pretty good number of folks here. So I'm not going to dive too much into what DevOps is. For people who weren't at the previous talk, John Willis gave a great sort of high-level definition about what DevOps is about. But at a really basic level, DevOps is about working well with your peers, both within your group, whether it's DevOps, security, networking, whatever, but actually working well with everyone, having actual empathy for your peers and what they're going through. Gary McGraw sort of talked a bit about this, I think in his keynote. He had this whole thing about the security people who walk into the development environment with a big report from one of these security tools or a penetration test, and basically throwing it on the table and laughing at the developers, or being the jackbooted security cop. That's not a lot of empathy there either. Whether you go in with anger or glee or anything else, if you're not going in with a sense of partnership or trying to get things done, you're actually shooting yourself in the foot. I will confess, I've been doing security for almost 20 years now. I have been the jackbooted security thug showing up to engineering, telling them they're doing it wrong. And I can tell you, it doesn't work real well. It doesn't make friends, it doesn't influence people. So that's something to definitely think about. John really, in the previous talk, talked about the importance of culture. Culture matters. It matters a lot. If you have a culture where there's an adversarial relationship between security and the rest of the world, it's really hard to get things done. You've probably all noticed that. And so transitioning from a culture of no, or you suck, or you're stupid, to how can we make things work really makes, at least has made my life a lot easier. And the need for things like Zantac has gone down a whole lot as a result of being a mellower individual. There's a lot to be said for that, but that's a different show, so we'll have to save that for another time. The first myth I want to talk about is that there's this huge idea out there in the security space that DevOps breaks separation of duties. And this really is driven by this idea of organizations who let developers push code to production. This flips people out to no end. They're like, developers pushing code into production? I learned in Security 101 that developers should never be allowed to log into production and make changes. And the fact is that when you talk about DevOps, what people talk about really here is some sort of automated deployment mechanism, whether it's using a Jenkins or some other continuous integration tool or a home-built tool to push code from production. I have yet to talk to a shop where a developer is physically logging into each server and pushing code live. That would in fact break separation of duties. But let's back up a little bit. I sort of got ahead of myself. What are the goals of separation of duties? What is the goal of having an operations person deploy code to production? There's two goals. One is the idea that, well, whoever's pushing the code to production will validate that that code is secure, that the developer, the evil, malicious developer, has not coded a backdoor into this stuff that's being pushed to production. Who here validates the code for security vulnerabilities before they push it to production if they're not on the operations side? No hands. And you know what? I do not know of a single organization who attempts to do some sort of code review or reverse engineering on patches that they get from their vendors to determine if there's a backdoor in that code. And it's a void point. The point, as the old SNL routine with Jesse Jackson say, The point is moot. No one does this. This has nothing to do with DevOps. This has nothing to do with engineers versus ops folks pushing things to production. The real concern here is change management. Change management, this is actually a real problem. How do you know what went into production, when it went live to production, and who pushed it to production? These are all these are serious, real security and operations concerns. Now, it turns out that the typical change management process when someone wants to put a patch into production is they may get some level of approvals or not, depending on their organization, and then someone goes ahead and pushes it to production. And then they go to their change management system and says, I'm David. It was 10:30 this morning, and I pushed the following patches to production. If I remember to actually go to the system and do it, or something like that. Versus your typical DevOpsian automated patch deployment system says, David pushed the following patch or the following lines of code to production at 10:34 and 38 hundredths of a second on this date. And so when there's a problem, we actually get much tighter change logging of what's going on. And so as a result, we're not actually breaking separation of duties. If anything, we're enhancing it because still no one's logging in. It's an automated system. So in fact, what you have is you still have individuals can't make unauthorized changes. And to the extent that they can make authorized changes, what you're looking at is where the approval flow happens. So when you have automated systems, you are approving a much larger range of actions that someone can take ahead of time. So even in the strictest change management shops I've worked with, like dealing with nuclear reactors and things like that, there's a certain level of things that people are pre-approved to do. They can create users, they can lock out users, they can make certain levels of access rule or firewall rule changes without having to go to a change management board. All we're doing here is broadening the range of things that someone is authorized to do in an environment before having to get to a human approval system. So no, we're not breaking change management. We're not breaking separation of duties. We're just doing it differently. Nothing wrong with different as long as you understand what's going on. Myth number 2, DevOps ignores security. Well, this is only half a myth. This is actually also a fact. The myth part is, and I'll get more into this in some later myths, is that just because you are doing DevOps doesn't mean you don't have security. Where security happens shifts. Just like when we went from waterfall to agile, where security happens shifts in the organization. You no longer in a DevOps world have a defined gateway of security. And much like in agile, you don't really have as much of a defined gateway point of security where a security person can stand there and say, I have manually run the following tests. I assert this is allowed to, this has met the magical bar. This is PCI, this is HIPAA, this is whatever. You're allowed to do the next step. You have to get into automation, and I'll talk more about automation in a little bit. And in that sense, there are opportunities in DevOps to do security. But where it's fact is that DevOps is happening, and you have an opportunity as a security person to be part of this equation, to be involved with the discussions, with helping automate security testing, by making sure that there's security-oriented unit tests and functional tests and integrated tests, and working in security products like the Vericodes and the White Hats of the world, where you can Qualys. I mean, the number of people out there on the show floor who have been API enabled so your automated test systems can run these tests, can validate that your product is secure enough for your needs, that they meet your bar for security to go to production or go live or whatever your requirements are. This is here. This is an opportunity for security people to embrace DevOps and move on and continue to be relevant to this discussion. And I think that's an important thing, is that this is an opportunity here with DevOps for security to remain relevant. There are organizations who, if we insist on remaining the gateway, insist on doing things the way we've done things in the past, they will ignore us. They will just go, they will do their thing, and we will in fact be left out in the cold. So this is actually only a half myth here about whether or not DevOps ignores security. I have to say, I think this is my favorite myth, actually, which is that continuous deployment, continuous integration means less secure code. The idea that code is going to production faster and more readily means that our code is less secure. And this could not be farther from the truth. There's some awesome research that's been validated repeatedly, but it started in 1979 at IBM Research up in Watson. And what the research demonstrated repeatedly was that as your feature set gets more complex in a product, in your software, the code gets exponentially more complex. Now, code complexity is a fact of life, but it's also one of the major factors that leads to security issues. If your code is the more complex your code is, the harder it is to identify security issues, the more likely it is that you're going to create a security issue, particularly once you get into the sort of business logic end of things. It's harder to track things down. It's harder to debug. But what this means is that if you do a series of small changes rather than larger blobs of changes, your code ends up less complex. It's a little basic algebra, but it comes down to that fact. So so there's just that. If your code is less complex, it's easier to debug. It's less likely to have security vulnerabilities, less likely to have bugs in general. And you end up with a more stable, more performant, more secure product as a result. Furthermore, the smaller your change sets, the less likelihood that any one change set will have a security bug in it, and the less likely it'll be that security bug, if it exists, is the kind of thing that will take down your site. Now, the cool thing when you start getting to these continuous deployment products out there, you push a code change, and it runs a bunch of automated tests on it, and it'll come back and say, David submitted the following 50 lines of code. He broke the following sets of unit tests or other tests. This is the line of code where it broke on this test or this series of tests. So suddenly now you have a very fast feedback loop, so you can respond faster to issues. You can identify issues before they even go to production. When you create an issue, you're now doing a build that, the build happened minutes after you created the code, not hours or days, which means you're in the thought process of, what was I thinking when I wrote that code? There's some other great research that started actually out of English departments and academic writing that found that the longer the period between someone writing something and them going back and reviewing it, the harder it was for them to figure out why they wrote it. What were they thinking of the process? What was the goal of what they were writing? What were they trying to say? Well, it turns out this research also applies to writing code. The longer the time span is between writing a piece of code and having to go back and fix it or make changes to it, the harder it is to figure out what you were thinking, what you were trying to do. The context switching problem gets harder and harder the longer the time span is between writing a piece of code and having to deal with it again. So if you can get incredibly fast feedback because you're only making a small change and you get those unit tests back, you can actually respond to broken code faster, which means your bugs have a shorter lifespan, and it's easier to fix the problem and less likely that attempts to fix it will fail. So this is all good stuff. But then, should this bug make it to production, and bugs make it to production all the time, the smaller your change set, the easier it is to troubleshoot. You can say, oh, hey, I pushed 25 lines to production and the site went down. I wonder what are the odds that the change is in one of those 25 lines of code? No, it could be that it's an interaction problem with some older code, but still, you have a pretty good targeted point where to look. And generally speaking, as long as you're avoiding things like schema changes, rolling code back out when it's a small change is significantly easier than rolling out a really big change. I mean, think about the difference between making a change to a configuration file or a router ACL versus applying a service pack to an operating system. I mean, it's much easier to fix a small change, roll back a small change. So so I kind of drew this out a little bit. But the point is that the smaller your change sets, the less complex your code, the less likely it is to have vulnerabilities or other kinds of bugs. And if there are, the easier it is to troubleshoot and respond, which means less downtime, which means faster. Not only do you have less downtime, you have less downtime in general. And when you do have downtime, your ability to get back up is faster. So you have, which is all good for your metrics. Your executives are happy that way. Your customers are happy that way. And what you end up with is a system that, even though you're changing it more often, is actually more stable. It's sort of counter to the general idea. And this is why, when your system is, when you're making a lot of changes, your system becomes less fragile. It's less problematic to be making a lot of changes versus sort of the old school system way of dealing with things where we had very reliable hardware, and not that reliable software. If you think about the way we wrote software for the enterprise, the Siebels of the world, the Oracles, the SAPs, we have pretty stable, these are designed to run on some serious hardware that's incredibly stable, and folks like my company and others make design hardware that is supposed to be ultra reliable because they know the software on top of it's not that reliable, honestly speaking. As we migrate to cloud, we're talking commodity hardware. Mean times to failures are a lot shorter, so the software has to become more reliable. And so you can't say, oh, my software's kind of, you can't get away with fragile software. You have to have solid software, which means changing it counterintuitively more often to get more stable software. I see a few confused faces. Are there questions about this? Okay. Myth number 4. DevOps and ITIL don't mix. Who here has to deal with ITIL? I'm even more sorry than the people who had to use Siebel. No, ITIL is not really a problem. ITIL is a really solid process-oriented way of doing business, especially on the IT side. It's service management, it's change management. There's nothing inherently bad about ITIL. Where ITIL becomes a problem for organizations, especially smaller organizations, is that it's very bureaucratic. It tends to have lots of meetings, lots of paperwork, sometimes literally on paper still, but it's process heavy in a bad way. There's a lot of, it's not very agile, there's a lot of opportunities to spin wheels, to have a lot of bottlenecks. There's nothing actually in the ITIL specifications that requires the bureaucracy. The bureaucracy is a holdover from the days, I mean, this stuff was starting to be built in the 80s, was holdover in the days when we didn't have a lot of automation, where computers were expensive and people were cheap, as Gary McGraw said in his keynote. There's nothing in ITIL to say you can't automate things, and there's nothing to say that the bureaucracy has to be there. So DevOps actually came out of, the term was coined, and the ideas behind it were first formulated by Patrick Dubois and others at an ITIL conference. And related to that is there's this myth that DevOps has no process, that people can just do whatever they want, whenever they want, wherever they want. And that's actually really far from the truth. DevOps relies a lot on automation, and automation is another fancy way of saying process. But the big difference between traditional DevOps, I mean, to the extent that there's any tradition in DevOps yet, and ITIL is that there's almost no bureaucracy in a well-run DevOps shop. There's a lot of process. Every DevOps shop I've talked to is process insane. They love their process. They want to know that they're doing the same thing the same way every time. That's all process is about, is consistent performance. ITIL is about consistent performance. Six Sigma, another dirty word in our industry, is also all about process. DevOps and ITIL and Six Sigma, these all play well together. Conceptually speaking, at a philosophical level, they're not actually that different. It's all about how we actually do things, how things are getting done on a day-to-day basis. So process, like I said, process is really about getting things done consistently the same way every time. Automation, whether you're using a Chef or Puppet, I love to use the examples of Chef and Puppet because people are familiar with them, but the awesome thing about these tools is they help remove the human element from issues. People are really bad at doing the same thing over and over again, the same way. We're not good at repeating things consistently. Computers, on the other hand, are really good at repeating things consistently. So I would much rather automate everything I can. I'm lazy. I would much rather have a computer push those, when I'm deploying my software, my team software, we deploy it in our SaaS environment to like 8 web servers, and I have no idea how many app servers these days in our database clusters and things like that. I don't want the ops team worrying about logging into each server manually and worrying about did they deploy everything the exact same way at the same time. They use Chef. No, it's quite possible that they're going to screw something up in designing the Chef cookbook, and as a result, it will be deployed improperly to all the servers, but at least it'll be the same way, which means that I'm not when I'm troubleshooting a problem, I can fix one server, and once it's fixed, I know how to fix all of the servers. I'm not standing around going, I have 12 servers here, 3 of them are acting this way, 8 of them are acting this way, and the 12th one is acting a completely different way. Well, which one's the right one? Is any of them the right one? Back in my Siebel days, when we started pushing Microsoft patches within 24 hours of Microsoft releasing them, because the attitude I came up with was, well, we'll deploy the patch on a couple of test systems. Does it blue screen? No, we're good to go. Now, it's quite possible that Microsoft will reissue a patch. But it's also quite possible we'll get the next SQL Slammer, Code Red, Nimda, whatever it was, and I would personally rather break the network in a way I understood that I had broken it, rather than a way that I had no idea what the heck was going on. And that's really, in a sense, what these configuration management systems are about, is knowing how you broke things. You're going to break things, that's fine. When you talk to the folks at Etsy, it's sort of if you're a developer and you haven't broken the website in the first week or crashed the website, then you're probably not doing your job. People are going to look at you funny. It's sort of a badge of honor to have done that. But so now process doesn't also mean no. DevOps doesn't mean no bureaucracy. So Facebook released, 3 years ago now, and they've updated now with a white paper, a fabulous video presentation of how they do release management. And they're a very DevOps-oriented shop. So they have, 10,000 developers now? I have no idea. I lost track. They have thousands upon thousands of developers. They have a release management team of 3 people who manage their entire release management process because they've automated a lot of things. And in order for code to go in production, every single code you write at Facebook is manually code reviewed. Doesn't matter if it's security-oriented code or not. Every bit of code gets code reviewed by a colleague. Has to be done. Every single bit of code that you commit to the repository, and by the way, they have one repository for the entire Facebook site, and so it's big, goes through an onslaught of automated security testing and performance testing and whatnot as well. But it doesn't automatically deploy to production. There's a release management team who actually manages that release cycle. So there's a little bureaucracy, but there's still a lot of automated process. In order for your code to go live in production, this is really cool. You log into the internal IRC server, you authenticate yourself to the bot and say, here I am. I'm ready for my code to go live as a developer. If you don't check in with the bot at your go live window, your code does not get pushed by the release management team. It doesn't matter who you are. It doesn't matter how important your code is. If you can't be bothered to be logged into the system to say, I'm ready to support this code if it breaks something, even in spite of the code reviews, even in spite of the automated system, you just missed your window. You get your next window, and it could be a week. Because the risks, of breaking something at a site of that magnitude without the ability to respond quickly are a problem. So some companies have a little more bureaucracy than others, but again, DevOps does not mean no bureaucracy, doesn't mean no process. It doesn't mean you can't do ITIL at the same time. It's just where the humans end up in the process shifts a lot, and it depends a lot on your organization, what your exact needs are. Auditors hate DevOps. I hear people say all the time, oh, I can't do DevOps, my auditors won't let me. Have you talked to your auditors about DevOps? Did your auditors just magically show up and say, oh, okay, you can't do Agile. You can't use PHP. Well, actually, that'd be a good one. No, you can't use JavaScript. There are auditors who will freak out when you say we're doing DevOps because they don't understand it. This is not inherently a problem. It just means that you have some education to do to explain where your actual controls are and saying, look, you're used to seeing this control as a manual process. Here's how we've automated it. Here's how we're validating it. Here's how we can show an audit trail around this. Anyone here doing infrastructure security in the early 2000s? Okay, so there was a handful of folks. You remember when your auditors would show up and you'd say, hey, I'm using Qualys. And your auditors would say, whoa, how do I know? I need to run a scan myself. And a bunch of us spend a lot of time working with our auditors to explain to them how Qualys worked and how we didn't actually have the ability to remove results or or alter how things were. And we could show them, here's the report we configured to run, here's the results, hand it off to the auditors. And the auditors said, oh, so it's not really that different than us showing up with a copy of CyberCop. I just showed how old I was. Or Tenable or whatever products we happen to be using at the time. And so there's an education problem. Auditors don't hate DevOps. They don't hate Agile. They do like PCI. They do love our regulations, but there's nothing here that says you can't be audited. You could build a DevOps environment that doesn't actually demonstrate the things the auditors want to see, and you know what? They'll tell you what they want to see, and you can make that happen. But in terms of the big thing here is change management, as always with auditors, and the tools, the chefs, the puppets, the CF engines, and the related tools do a much better job of auditing than we do, and they have the added benefit of that if everything has to go through your CI engine or your chef or puppet, it means that you also see the unauthorized changes. If a employee is misbehaving and says, I'm gonna go ahead and create a local user on this machine, so I have a backdoor in, they're not going to go to the change management system and say, hey, I put a backdoor in. That would be kind of foolish, and it wouldn't make them a very good miscreant, would it? However, if they go into Chef, because that's the only way of making changes to the system and deploy a new user on the systems, it's there. It's easy to audit. It's easier to see what's going on. And these tools, the chefs and the puppets, have an added benefit of that they actually have tripwire-like functionality. Anything that's being managed by those puppet manifests or those chef recipes, basically, the agent looks at that and says, whoa, someone just logged into the local server and made a configuration change to the database. Well, I'm managing the database. That change is unauthorized. And it rolls it back. It puts it back to the way it thinks it should be, much like Tripwire does. So you get a little added security that wasn't sort of in the advertised scope of what's going on there in terms of your configuration management. Your configuration management systems, the auditors love this. They become a CMDB of sorts. Anything that's managed by your chef or your puppet is now a CMDB. You can say to your auditors, whether it's from the BSI or whatever, or they want to say, well, how many machines are running Oracle 11 GR2? Well, I go to Oracle and I go to Chef and I query the database and I can say, look, I have 12 servers running Oracle 11 GR2 with the following hotfixes that I pushed. Oh, and by the way, I can tell you that it took exactly 68 minutes for all the following patches to push to Linux across my environment. And I can tell you that actually I'm only currently at 98% compliance because this box is not checked in recently. Can you do that with your current tools? Maybe, maybe not. Certainly if you're not running a Big Fix or some of these other tools, sort of a second generation product like that, if you're doing it manually, you certainly can't do that. So no, auditors will like DevOps. One of the things you want to talk to when you're dealing with your auditors, when you interview your auditors, especially from some of the larger firms, is understand who you're getting. In a lot of cases, when you start dealing with the really big audit firms, if you get sent a, shall we say, less experienced auditor, fresh out of training, they may not have the authority to accept something new, or they have their checklist. They're only allowed to follow their checklist. That's what they're allowed to do. And so when your auditors come in, talk to them. Actually, before they come in, when you're negotiating the scope of work, find out who you're bringing in. Find out if they have the authority to even listen to you about, what are your compensating controls? How are you doing things outside their level of expectation? And if they don't, insist on getting an auditor, or at least a member of the management team for those auditors, who has the authority to sign off on compensating controls, who understands what compensating controls mean. things like that. So it's not an inherent thing. This is not a black or white issue. Auditors, the ones I've worked with, once I explain DevOps to them, are like, that's really cool. Because it is. And I call this fact number one. Actually, it's now, I guess, fact 1.5, because I talked earlier about DevOps and security and ignoring it. We can't ignore DevOps. It's coming. It's here. It's the trend right now, especially for a lot of organizations. So it's definitely one of these scenarios where we can get on board or get run over. And sort of blindly saying that you're not going to accept DevOps is kind of like blindly saying I'm not going to accept Agile, or I'm not going to deal with PCI or any other regulatory framework. It's here. How we interact with it, understand, ask your organization, what do you mean by DevOps? What are you trying to do? What are the goals here? I mean, DevOps, like I started off, is a philosophy. It's a cultural phenomenon, like John said in his talk in the last session. So understand, what does DevOps mean for that organization? What are they trying to do with it? And take the opportunity to be part of DevOps, even if you don't agree with it personally. Thank you very much. Any questions?
Yeah, so hey, really got tripped up on how you asked the question. Anybody at Ops, we actually do review everything.
Right.
But what I was going to ask, because I love the whole thought of this, and I really do want to embrace it. I see a bigger problem that I would love when I got some resources on how do you culture change to get the developers and the QA people to accept it. Because it's been a history of months.
Right. I mean, how to convince people to do something they don't want to do is sort of one of the great management problems of all time. One of the things I found when in organizations I've worked with, DevOps has actually been pushed by the development organization. But in the cases even where it wasn't, the idea of going to folks and saying, hey, this is an opportunity to work on the hard problems and not have to do the same grunt work over and over again. Like John said in the previous session, there's a Pareto principle here, the 80-20 rule, and the goal is to migrate from it being 80% grunt work to it being 80% fun work. And when I talk to folks, whether it's in security or ops, I say, hey, let's just automate a few things here. Let's talk to each other and understand where the problems are. And people are like, they want to do it. I mean, the thing is, no one likes doing writing the same 12 lines of code over and over again. They don't like doing the manual testing on the QA side or the dev side if it's sort of especially a lot of startups, it tends to be the same function. It's like, I see a lot less of this rhetoric now, but there used to be a lot of rhetoric around developers don't want to write secure code. Most people enjoy their jobs, and they want to do a good job at their things, and they get really bored doing the same stupid shit over and over again. And the culture on DevOps really helps towards orienting towards getting rid of as much of the grunt work as possible by automating it.